In this lesson, we are going to discuss V-Ray wrapper material or V-Ray MTL wrapper. Using wrapper material, we can define additional surface properties per material. The same set of functionalities that wrapper material offers is available on a per object basis. The first thing I want to mention here is the car model in this scene won't be provided with the project file. You can use your own model, or I have just created a simple chamfer box here that you can use if you want to, or you can use your own car model. It really doesn't matter because we are trying to understand the concept and how it works, and the model, it really doesn't matter that much what you use. If I select this plane, right click on it and choose V-Ray properties, we get a series of surface properties. Wrapper material offers some of these parameters in this window on a per material basis. Options like generate and receive GI, generate and receive caustics, caustics multiplier, and all of the math properties on the right side of this window are available in the wrapper material. And it really doesn't matter you use them here or you use them in the wrapper material, but the wrapper material, if you use them, it will actually override the options in the V-Ray properties window. Now let me close this window and open up the material editor. And let's add a V-Ray MTL wrapper material. As you can see, we have the GI and caustics options and also matte properties. If you change the parameters for an object in the V-Ray properties window, then adjust the same parameters in the wrapper material and assign it to that object, the parameters in the material will override the ones in the V-Ray properties window. Now let's select the plane object and assign the wrapper material. In a moment, I'm going to show you a practical example of how to use this material to blend your 3D models into a photographic backplate. But for now, let's just go over some of more obvious parameters. In the base material, we can define the actual material we want to use. In the additional surface properties section, we have generate and receive GI, and these are multipliers to control the global illumination generated and received by the surface that has this material. For example, if you set generate GI to 0, there would be no GI contribution by this material, and if set to 2, the GI contribution will be twice as strong as when it was 1. And receive GI the same way. If set to 0, the GI from other elements in the scene wouldn't affect the object that has this material, and if set to 2, it will receive twice as GI. Obviously 1 is the physically accurate number, and you shouldn't mess with this value unless there is a specific need. We have generate and receive caustics. We'll be discussing caustics effect later on. Generate caustics control whether the material generate caustics effect or not, and receive caustics controls whether the material receives caustics or not. And we have this caustic multiplier to control how much caustics effect the surface that has this material will receive. Now, as I mentioned earlier in this lesson, we can use the matte properties section of the material to blend 3D models into photographic plates. To do so, we need to prepare our scene and set it up correctly. Let me close the material editor and get back to this scene. To integrate your 3D models to a photographic plate, you need a backplate or a photographic plate and the matching HDRI for that plate. For this lesson, I'm going to use a free HDRI and a free backplate so everybody can have access. If you go to hdrmaps.com, in their freebies section, you can download an HDRI and its matching backplates called Road in Tenerife's Mountain Landscapes. So go ahead and download those. We're going to be using the HDR image and one of the backplates in a moment. Now first, let's get started with the lighting, as we don't have any light in the scene right now. add a V-Ray dome light to the scene. In the Modify panel, click on the Texture button and choose V-Ray HDRI. And select the HDRI that we just downloaded. And also let's open up the material editor and drag the HDRI map to the active view. If we render the scene right now, the result would be render 0, 1. We really don't need to see the HDRI image, we just need its lighting contribution. So in the options rollout of the light, let's make sure it's invisible. Now we need to define the backplate photo as the background. Open up the Environment and Effects window by pressing 8. Click on the Environment Map button and choose Bitmap. And select this backplate photo. In order to see this photo in the viewport, we can simply press Alt and B to open up the background tab of the viewport configuration window and choose Use Environment Background. Now we just need to change the mapping type of the map. So open up the material editor and drag the environment map to the active view. Change its mapping type to environment and screen. Now if we render the scene, the result would be render 0, 2. The next thing we need to do is to make sure that our HDRI is aligned with the backplate photo. To see the HDRI image in the viewport, let's simply instance it as the environment map. And because the viewport background is using whatever map is in the environment slot, we can see our HDRI in the viewport. Now let's try to align it based on our photo. For now, let's hide the plane geometry so we can see the HDRI a bit better. Let's try to rotate it horizontally, maybe 100 degrees, 200 degrees, 300 degrees. I think we need to flip the image horizontally. Yeah, let's try 325, maybe 350. I think something like 355 would be enough. Yeah, 355 is our magic number, and if I select the backplate photo and click on View Image, you can see the HDRI is aligned very closely. Now that we are sure our HDRI is aligned, we can reassign our backplate photo to the environment map slot. Let's make sure the mapping is set to screen again and unhide the plane. And if we render the scene right now, the result would be render 0, 3. Now compared to our previous render, the lighting is more natural, but still not perfect. Now let me just close this window for now and also hide the plane. Another aspect of integrating 3D models into backplates is the camera, obviously. In this scene, I use Perspective Match utility in the Utility tab, and it's a very simple tool. You need a free camera without any target to start with. Then you activate the Perspective Match utility while you are in the camera view and enable Show Vanishing Line, and then simply try to move these lines and align them with the straight elements that you see in the scene. Unfortunately, we don't have enough time to explain this tool here, but you can check out the 3ds Max's guide and learn about it. Now let me just disable the tool here, and you can simply eyeball the camera the way you want it to. Now it's time to unhide the plane and assign our wrapper material to it. For the base material, let's for now use a simple gray V-Ray material. In the wrapper material, the first thing we need to do is to enable matte surface. Matte surface makes the material appear as a matte material, which shows the background instead of the base material when viewed directly. Note that the base material is still used for things like GI, caustics, reflections, etc. Okay, and I took that definition from V-Ray's guide. Now if we turn on shadows, the matte surface can actually catch the shadows cast by the car from the environment. So if we render the scene right now, we are going to get render 04, in which the car is integrated nicely with the back plate. It's not perfect yet, but you know, it's good enough. One problem that we have right now, and I'm not sure if you have noticed it or not, we can see the plane is still affecting the back plate. On these rocks, for example, close to this green sign, we can clearly see where the plane is, and it's affecting the color of the back plate. And at this line where the boundary of the plane geometry is ended, we can clearly see this separation, right? The reason for this problem is the environments map that we have defined in the environments and effects window actually affects the lighting of the scene. What we can do in the render setup dialog is to override the effect of the environments map on our GI and reflection using the environment rollout. In this rollout, enable GI environment and reflection refraction environment, and make sure the colors are black. Now these black colors will override the environments map in the environments and effects window for GI, reflection, and refraction rates. Now if we render the scene right now, the result would be render 05, which eliminates the previously mentioned problem, and also the overall lighting has changed a bit because the map in the environment slots no longer affects the GI, reflection, or refractions. Now we are good. Let's close these extra windows and get back to our wrapper material in the material editor. Next we have alpha contribution, and I'll be quoting V-Ray's guide. Alpha contribution determines the appearance of the object in the alpha channel of the rendered image. A value of 1 means the alpha channel will be derived from the transparency of the base material. A value of 0 means the object will not appear in the alpha channel at all and will show the alpha of the objects behind it. A value of 1 means that the transparency of the base material will cut out from the alpha of the objects behind. Matte objects are typically given an alpha contribution of -1. Note that this option is independent of the matte surface option. That means a surface can have an alpha contribution of -1 without being a matte surface. In the first render, alpha contribution is -1, then 0, and finally +1. Let's set the contribution to -1 for now. We have matte for reflect refract. This option makes the material appear as a matte material, which shows the background instead of the base material when viewed through reflections and or refractions. Let me quickly show you what that means. We have this box in the scene with a reflective material applied to it. Let's unhide it and let me show you two renders with matte for reflect refract option enabled and disabled. In the render with matte for reflect refract off, you can see the reflective box is reflecting the plane with its gray material, so it doesn't consider it a matte object. But in the second render with matte for reflect refract on, you can see the reflections and the refractions are considering the plane to be a matte object and reflecting the environment correctly. Let's for now hide this box. Also, let me run the active shade for the rest of these parameters. We have shadows, and when this is enabled, the shadows will be visible on the matte surface and the surface will act like a shadow catcher. We have effect alpha. Turn this on to make shadows affect the alpha contribution of the matte surface. Areas in perfect shadow will produce white alpha, while completely unoccluded areas will produce black alpha. Using this color, you can change the color of the shadows on the matte surface. Brightness is like the opacity value for the shadow. When set to 1, the shadow will be visible completely, and as we decrease the brightness value, it becomes less visible. The shadows become less visible. We have reflection amount, which if the base V-Ray material is reflective, it will show that reflection. Let's make our base material a tad reflective and you can immediately see how it works. And the way this option can be useful is if you imagine the road was wet, for example, and you wanted to see the reflection of the car in the road, you would use a reflective material as the base material and make sure the reflection amount in the material wrapper is larger than 0. We have refraction amount, which shows the refraction from the base material, and a very important option, which is GI amount, and this determines the amount of GI shadows. In the active shade, you can notice how the white color of the car is affecting the GI on the matte surface. Maybe it's a bit too much in this case, and if I zero out the GI amount, you can see the GI shadows from the car on the matte surface is gone. Now let me stop the active shade and show you a few renders with different GI amounts. In the first render, GI amount is 0, then 0.25, then 0.5, and 1. In this case, let's set the GI amount to something like 0.15 maybe. We have no GI on other mattes, and this will cause the object to appear as a matte object in reflections, refractions, and GI for other matte objects. And GI surface ID can be used to prevent the blending of light cache samples across different surfaces. If two objects have different GI surface IDs, the light cache samples of the two objects will not be blended. This can be useful to prevent light leaks between objects of vastly different illumination. So that's about V-Ray wrapper material, and as I mentioned, you can have access to the same set of options on a per object basis using V-Ray properties window. Another thing to mention is that the render output size is going to be 1500 by 1000, which is the exact dimension of the backplate photo. Now for the final render, I've noticed one problem in our renders. You can see the refractions are black and we cannot see the other side of the car. So let's open up our render setup, disable refraction environment override, and for the refraction environment, I'm gonna copy the HDRI map that we have and use it as the refraction environment override. Now we're gonna be talking about the environment rollout and understand exactly what these options are here for, but I've explained it a bit in the beginning of the lesson, and I think that would be enough for now. Now if I render my scene, the result would be render 06. It's good, but I just don't like the way the screen sign is appearing on the glasses of the car. So In the material editor, let's rotate our map by 5 degrees, so 0 basically. And now in the render 07, you can see the problem is gone. And in the frame buffer, you can take a look at the final render, which is a beautiful and realistic integration. And I've used the irradiance map and light cache for the final render, and you can right click on the image and load the render settings to see what exactly are the render settings. And I've used the brute force and light cache throughout this lesson, but for the final render I decided to go for irradiance map and light cache. Okay, I'm gonna go ahead and save out this render as a 16-bit EXR and open it up in After Effects to do some quick post works. Here we are inside After Effects, and let's quickly do some dirty post works. First, load the render and create a new composition based on it. Again, make sure that our project is a 16-bit project. Add the Magic Bullet Film plugin from Red Giant if you have it, and select the first Fujifilm preset. Set the film grain to 25% and vignetting to 20%. Finally, let's add an exposure effect and increase the exposure by half a step. So set the exposure to 0.5. And we can finally add a hue and saturation effect and decrease the saturation to -20. I'm gonna just try a few other presets and save out a few versions, but that would be enough for now. So in this lesson, we'll learn about V-Ray wrapper material and how to practically use it. I will see you in the next lesson.